Hello everyone, welcome to the YouTube channel I am Chemistry. So today's topic is Maxwell's relation. Maxwell's relations are a topic in chemical thermodynamics of physical chemistry. So we are today expecting that Maxwell's relations is all clear in our minds. So there are four Maxwell's relations which are which are studied as which there are generally four Maxwell's relations in which the various expressions connecting internal energy, Gibbs free energy, work function, and not work function, Helmholtz free energy, enthalpy. These are connected by putting several parameters with temperature, pressure, volume, etc. With these three entropy, with these four types of things, so they are written as the first is du is equal to TdS minus PdV. This is the first relation for the internal energy. Then we have the second dH. This is for change in enthalpy, so small change in enthalpy. This is TdS plus VdP. This is second equation. Then we have third. The third is small change in Helmholtz free energy, which is minus SdT plus not plus minus PdV. This is, let's call it, third equation. And the fourth relation is for small change in Gibbs free energy, which is minus SdT plus VdP. This is fourth, let's call it fourth equation. So now we have these four equations. So the first thing which comes in our mind that how to learn how to learn these four relations, because these are not very appropriate, and we have to learn these because these four are used in the all the relationships we are doing in these things. So there is an analogy used by several times, which is as follows, this is like there is a Maxwell square. This is a Maxwell square. So as we see that in this Maxwell square we have the four parameters, that is volume, temperature, pressure, entropy. These are written on in such a way at the corners of that rectangle, and the four the way and the four important things, that is internal energy, enthalpy, Helmholtz free energy, and the Gibbs free energy, are written as follows. There is Helmholtz free energy, there is internal energy, and there is Gibbs free energy, and the last one is enthalpy. So let's take a look at how to use this to acquire these four relations. So in these there is a rule that the property heading the arrow is taken as negative. Head of arrow is taken as negative, and the tail of arrow is taken as positive. So let's take a look at let's take a look at let's take a look at these things. Now we have uh, uh, with the use of this, let's calculate this. So I am going to calculate these things with the help of this square. So the first of all, I have let's calculate for du, which is change in internal energy. So for this thing we have to go through this line, that is uh, where is u is written, where the u is written, those two are written as ds and dv, change in entropy and change in volume first of all. Then we have volume in front, in the diagonal relationship of volume we have p, that is written, and uh, in the diagonal relationship of s we have t. Now we have a thing that what is between, now we have to put sign equivalent. So as I told you that we have to put minus to the minus to the arrow which is coming towards the head. So pdv, that in that way that that the tail has positive but the v is on that side, as we are concerning internal energy relation. So this is v, and we put the, this is at first relation, this is the first relation, in that way. Now let's take a look at dh. Similarly, let's go to dh, where we have, let's go to dh where we have entropy and pressure. So let's again ds and dp. Now in entropy, in the front of entropy we have, in diagonal relationship we have t, and in the diagonal relationship with the p we have v. And now what is the sign between them, then again this thing arrives. But because in this case the arrow is emerging from this, so it is taken as positive. I hope these things are clearing in your mind. And let's do similarly, let's do it for dA, which is d, where is dA? So then dv and dt. In diagonal relationship of v we have p, and in diagonal relationship of t we have s. And now let's take a look at the sign between them. So pdv and sdt. So in both these cases the arrow is coming towards them, so they are taken as negative, and it is also taken as negative because the arrow is emerging towards them, v and t. And the fourth relation I am writing it here, that dg, the change in Gibbs free energy, which is written as g, we have dp, change in pressure and change in temperature. So temperature s and pressure we have v, and let's put the sign between them. It is v dp minus s dt. There is minus sign comes between them because the minus is the uh, because the entropy have emerging arrow. Okay, so this is the fourth relation. Now we are going to use these four relations, and we have to calculate the what is the relationship between these two equations, like first, second, third. For first, second, we are going that in first, second, what is the relation, first, third, what is the relation, then first then second and third,